morning. My name is Raghu. I am a student of Shanti Bhattacharya. Today I will give you a tutorial on Python programming language. So we are teaching Python here so that you can model some of the optical elements and optical phenomena that you have studied in this course. For example, a lens or a Gaussian beam. So this is the tutorial. So all of you have already installed Python. You have it. Maybe if you haven't, maybe you can sit with somebody who has Python installed. So the idea is, so you do when I do it here, do it along with me. Okay? So I request all of you to install Python before watching this video, and try the Python commands along with me. Okay. Python is a very easy programming language and it's very popular nowadays. So if you see machine learning applications or scientific computations, Python is very widely used, and Python is very easy to install. Python is very easy to learn also. So if you already know some other programming language like C or C++, you can easily learn Python, because if you take any programming language, the basic building blocks of the programming language are same. So these are the important topics that I will be covering in today's tutorial. So basic programming style of Python, and what are the different types of variables like integers, floats and booleans, and what are the arithmetic operations on these variables like adding two numbers, division, multiplication, and we need some comparison operations to see if a number is greater than or less than a given number, and strings to give some sentences or something like that, and conditional statements to see if a given condition is true or false, and finally the most important thing is iteration, because if you have some computation in your program and if you want to do it many times, like 100 times, instead of writing the same code 100 times, you can use an iterative approach like for loop or while loop to do it a number of times. And finally, we will see vector data types, which is like array to store similar types of data types. Okay, so now let's go into some brief history of Python. So Python was originally invented in 1980s, and it was first used for word or text processing kind of applications. But later on, because Python is very easy to learn and it has a very powerful inbuilt library, people have adopting it by Python in different applications. So now Python is used in many applications ranging from academics and machine learning and a lot of applications. And Python is a scripting kind of language, and it's interpreter based language, not like C or C++. So which is a compiler language. So what is the difference here is, so in C language, if you write a program and if you compile it, the whole program gets compiled and then after that you execute the program. But in the case of Python, so if you write some 20-line program, so the interpreter will take one line, executes and then goes to the next line. For example, if you have some error in some 10th line or some, so the interpreter goes to the 10th line. If there is an error, it stops there and it doesn't execute the next lines. But in compiler, it will compute the whole program, even if there is an error in somewhere in between of the program. And it's an object-oriented programming language. And we are not covering this particular aspect of Python in this lecture, because it's beyond the scope of this course. Okay. And these are the advantages of Python, because it has very big library, open source library. Most of the functions are already written by some other people. You can just directly import those libraries here. And it's open source. If you have some doubt, you can just post your question on Stack Overflow or some other website. You can get solution within few minutes. And it's very easy. The syntax of Python is very similar to English language. So when you write program, you actually feel like you are typing English sentences. Okay. The biggest disadvantage of Python is it's very slow compared to C language, because C is like a very lower level language. Python is very higher level language. Okay. So this is a brief overview of Python. So now let's go into how a Python program is written. So what is the style and syntax that we use to write a Python program? So the when you see a Python program, the first difference that you encounter is the semicolons that you use in normal programming like C or C++. So, where you put a semicolon after end of each of these statements. Sorry, there was a mistake. So, there should have been a semicolon here as well. But if you see a Python program, there are no semicolons after each of these lines. Okay, so you don't have to end your statement with a semicolon. So, that is the first difference to any other programming language. And the second difference is, so if you see C program and if you are writing an if statement or a for loop, so whatever code that gets executed in a if statement should be enclosed in a open and closed braces, so that your program knows, okay, this is the content I have to execute in this block. But in Python, we don't use these curly braces. Instead of that, what we do is we use this colon operation, symbol. So after colon symbol, if you if you press enter button, so the program doesn't start from this point, it shifts to some 5 spaces to this location. So Python interpreter will know, so which part is included in this if statement by looking at this extra space. So whatever lines you write after if has this amount of spacing, they will all be considered as part of the if statement. Okay, that is another significant difference between other programming languages and Python. Okay, and yeah, this is what I meant before, the space. This is called indentation. Okay, this extra space is called indentation. So if you see here, after if statement we have used the colon, and then after that we gave this indentation. So this particular statement comes under the if block. Okay, and next we have moved back again to this point and we have written the else statement, and again a colon operation, and we have given the space so that the interpreter will know. So this line is part of the else block. Okay, so this is the second major difference between C and Python. And if you see the third one, so in C language, so we have defined two variables A and B, and we have declared them as integers by using the keyword int. Okay, but in Python, if you see these two statements, we have not specified whether it is an integer or float or different the type of the variable. So what happens is, when you write A equals to 2, the Python interpreter will itself take care of this assigning the type to the variable. Okay, so A is by default declared as integer because we have given it to. So this simplifies the Python programming very much. So you don't have to worry about variable types or anything, you just write like English sentences. So this is the third difference. And in C program, so your execution of the program starts in the main method, right? You all know it. So in order for your program to be executed, you should have a main function. So this is a main function. But in Python, you don't have to write any main function. You can just keep writing several statements. They all get executed one after another. Okay. So these are the differences between C and Python, and this is a typical style of writing a Python program. Okay. So now let's move on to different types of variables in Python. So in any programming language, you should have a variable type to store a particular data value. For example, you can store it integer, you can store a float value. Float values, I mean, which have decimal parts. Integers don't have decimal parts, but floats have decimal parts. So you need variables to store these values. And in Python, we have 3 types of variables, which are integers, ints, floats, and Boolean variables. So Boolean means true or false. It has only 2 values. So to demonstrate how do we use variables in Python, so I want to just introduce to some simple program. So don't worry about what I have done in this program. I will explain. So what we are trying to model in this example is what happens when light travels in a medium. Okay. So we all know these are 2 light waves traveling in this direction, and the upper light is traveling in a medium with a refractive index of 1.5. So we can say this is a glass material. On the other hand, the lower material is traveling in a air medium. So and the refractive index is 1. Okay. So because of this refractive index difference, so the output light is going to have a phase difference. Okay. So that extra phase accumulated by this light because of traveling in this medium can be given by this equation. Okay. So this is 2 pi by lambda, which is also called the wave number, and n is the refractive index, and d is the thickness of this material. And if you see in this region and in this region, so there is no difference in phase between the upper and lower rays, light waves, because they are traveling in air in those regions. But if you see in this region, the upper one is going in glass and the lower one is going in air. So there is a phase difference. So how do we calculate this phase difference? So delta phi is given by phi 1 minus phi 2. So where phi 1 is 2 pi by lambda into 1.5 into d, minus phi 2 is 2 pi by lambda into n is 1 here, and distance is same. Okay. So the overall phase difference is given by 2 pi by lambda d into 1.5 minus 1. Okay. This is the phase difference between these two waves. So this is the same thing I tried to write a Python program. So here pi value is assigned to a variable called pi, and we have not said it is an integer or float here, because the Python interpreter will itself take care whether it is an integer or float. So by default pi is going to be a float type of variable. Okay. And wavelength of light we are choosing as 633 nanometers. Here nanometers, instead of writing 633 to 10 to the power of minus 9, in Python we say e into e minus 9, which means 633 into 10 to the power of minus 9. Okay. And I just chose some randomly the wavelength 633 nanometers. We can choose any other wavelength. And Ng is the refractive index of glass, and Na is the refractive index of air, and d is the distance travelled. I just took it some 10 into 10 power minus 8 meters, and k, the wave number, I have calculated using 2 pi by lambda formula, this one, and phi 1 is the phase difference, and this is the equation, and phi 2 for this equation. So delta phi is given by phi 1 minus phi 2. Finally we are printing the phase difference between the waves is given by so and so number. And another thing you have to notice here is this statement. So d phi is a float type of number. Okay. So in order to print it on the screen, we need to convert it into a string. So that is what we are doing here. So this is a keyword str. So if you write str of some number, it will convert into a string. It will add this to the previous thing using this plus operator, and it will print on the screen. Okay. String is a series of characters. It's like a sentence, English sentence. Okay. So now I'll just show quickly how to run this program. So this is the software that I asked you to install, which is called Canopy. So to open this, you just go to programs and thought and code editor. If you click this, so you will see the screen. So I already opened it so that it doesn't take a lot of time, and I have already stored this okay, this is the program. I will increase the font size. Can you see it now, or you want it still bigger? Is it okay? Okay. Yeah. So I will explain how to use this software in few minutes, but for now just see so the program running. So this is the program, and this is the button you have to click to run the program. So now here it is asking, it's just giving the phase difference between the two waves is 0.49 radians. Okay. So now we have seen some example program. So now let's go into deeper about what are variables in Python. So as I have said before, in Python there are three types of variables: the integers, floats, and Boolean type of variables. So integers, they are all real integers, so they don't have fractional part. And in integers there are 8-bit integers, 16-bit integers, so you don't have to worry about it. The more number of bits you have in integer, the bigger number you can represent. And similarly float, you can represent decimal numbers, and Boolean, it has only true or false values. Okay. So now I want you guys to open the Python shell so that you can try some of these commands by yourself. So to do this, I hope you already installed the software. Just go to the same nthought. Here you just open this Canopy command prompt. Okay. So I have already opened it, and this is how the command prompt looks. Okay. So this is called the Python shell. So in Python shell, what you can do is, instead of writing a big program, you can just give commands one at a time. Okay. So for example, I am showing you, we can say a equals to 1 and the value of a is stored in the Python in memory. Okay. So when you just in the next line, if you say a and it prints out the value of a as 1. Similarly, you can say b equals to some 49 and if you say b, it will give the value of b back. You can also try print b, it will print the value of b. Okay. So now now we have seen there are 3 types of variables and there is a command in Python to know what is the type of variable. Okay. So for example, we know 2 is an integer variable, but we want to know what is the type of variable. So just go to this Python shell, we can say print type of a. So since a is an integer type, it will print the type of a as int. And we will see another example where we see pi equals to 3.141 and now we will ask the Python to say what is the type. So it gives the type to be float. Okay, these are the simple commands that we can use to know the type of a variable. And similarly, we will see what happens with a Boolean variable. So I will just say t true and so t is a Boolean type of variable. So in for example, in your program, sometimes what happens is, so you have a variable that is an integer or float, okay, but you want to convert from integer to float or float to integer. So in Python there is a way of doing it. So if you have a number 3 which is an integer, if you want to convert it into a float, so you can use this command float and you pass the number that you want to convert it into float. So now here 3 will be converted into 3.0, okay. And similarly you can convert this 4.3215 which is a float number into integer by using this int of command and it will return the value 4. So we can just quickly try those commands here. So it gave us the value 5 back, you can give 5, so it becomes 5.0, okay. All of you are trying or you haven't installed? Yeah, I highly recommend, because you guys, if you do when I do, it's faster, you can learn Python very fast. Okay, this is called type conversion or typecasting in Python, to change one type to another type. And we have seen variables and now we will go on to what are the type of operations that we can do on these variables. So the first type of operations called arithmetic operations. So by name itself it says arithmetic means addition, multiplication, division, subtraction and so on. So these are the symbols used to do these operations in Python. So plus is addition, minus is subtraction and hashtag we use this for multiplication, and division symbol we use for division. So we can quickly try these things in Python shell. So we can say a equal to 5 plus 3 and we just say a, it gives the value a. Similarly, or else we can just type 5 into 3, it's 15, and 5 minus 2, 3 and so on. Yeah. So if you had noticed here, 4 divided by 3 should have been 1.333, but here both of these variables are of integer type, so the result of this computation will also be integer. So this is another thing you should always keep in mind when you are dealing with integers. If you are just dividing two integers, you should always take care, at least convert one of them into float so that the result will be a float, otherwise you will lose, some mistake will happen in your program and you don't realize, you will get some error in your output. So these are the basic arithmetic operations, and there are other operations. For example, this percentile operation which is a reminder operation. So if you want to know a reminder when you divide a number with another number, you can use this percentile symbol, and if you want to calculate power of a number, you can use this double hashtag, okay. Single hashtag is for multiplication, and if you use two hashtags, it's power. So let's quickly try those things. So 5 percentile 2 is 1 and 5 power 2 is 25. Okay. So now we have seen these. Okay. Yeah. So another important thing that you have to keep in mind when using these arithmetic operations is that where you keep your parentheses. For example, if you have a line of program, so that has so many arithmetic operations like additions, multiplications and divisions, and you have to keep your parentheses properly. Okay. Instead of writing 5 plus 3 in brackets, if you write 5 plus 3 into 2, so what happens is the result will be, can you just tell? It's going to be 11 instead of 16. Okay. So you have to keep in mind where to put your brackets correctly so that you will get the desired result. And in Python, operations are executed from left to right in this order. This is the precedence of operations. So first is the power operation, then multiplication, division, addition and subtraction. Okay. So now we have seen different kinds of arithmetic operations that can be done on both integers and floats. Obviously, we cannot do addition using Boolean variables. So now let us see what we can do with these Boolean, or how do we do comparison between two numbers. Okay. So in Python we have 4 types of comparison, actually 6 type of comparison. One is greater than or equal to, less than and less than or equal to. There are 2 more comparisons to check if 2 numbers are exactly equal or not equal. So to do this we use these symbols, greater than or equals to, and the order should be same. You cannot use equal and greater, this is illegal. You have to use greater than, equals to. Okay. Similarly, less than or equal to, and double equals to compare 2 numbers, and not equals to see if they are not equal. And many people make this mistake. So for example, if they say a equal to 3, so what happens is the value of 3 is assigned to the variable a, but by mistake, for example, if you want to see if a equal to 3, you have to use this statement. Beginners in Python or any programming language, they tend to do this mistake. When they want to compare, they just say equal to 3. So this is wrong, because here you are assigning the value to a and you are not comparing. So this is one thing that beginners should keep in mind. And a not equals to give so yeah, so the output of a comparison variable is always a Boolean type of variable. Okay. So when you are comparing two things, so outcome can be either true or false, it cannot be integer or float. Okay. So for all these comparison operations, so the output can be either true or false. So if you we will just try out some of these new comparison operations in the Python shell. So we can say 5 is greater than 3, which is true, and we got the outcome true. We can say 5 is equal to 1, which is false. We can also say 5 not equals to 5. Yeah, there is a syntax error, because there should not be any space in between the not equals to symbol and equals to. Okay, they should be next to each other. So since 5 not equals to 5 is a incorrect one, so we are getting the value false. Okay. And we have seen comparison operations can be performed on integers or floats. Okay. You cannot compare true or false with each other. We can compare using equals to, but not the other, greater than and less than. So now we will see what are the different kinds of operations that we can use on Boolean type of variables. Okay. So like these are the 3 allowed Boolean operations in Python. So which are AND, OR and NOT. So we all know what is an AND. If both A and B are true, then only the result of the operation will be true. In other cases, it is going to be false. Similarly, for A or B, it is only false when both are false, and in all the other 3 cases, it is going to be true. Not A is going to flip. I mean, if it is true, it is going to make it to false, and if it is false, it makes it true. Okay. And also we can use these comparison operations in conjunction with these Boolean operations. For example, if you see this statement, so 4 greater than 2 will give us a Boolean output which is true, and 1 less than 4 is also true, so the outcome will be true, and we have applied this AND Boolean operation between these 2 Boolean variables. Okay. So the result will be true, because true and true is a true. So now let us see what are strings in Python. So string is nothing but a sentence or group of characters that we write in Python. For example, in Python, the string always should be enclosed in double quotes, or you can also use single quotes. So both are treated as strings, there is no difference. For example, here optical engineering is a string, and you can also declare numbers as strings. For example, here 3.1415 is enclosed in braces, which means this is a string and not a float value. Okay. And you can also assign variables to string. For example, here uni is a variable and the value string is assigned to this variable. Okay. And let us see some of the operations that we can do on strings. So this is one operation that can be done on string. So here what happens is, as we have declared earlier, so the variable uni is assigned with a string called IIT Madras. When I say multiply it with 3, what happens is the string is repeated 3 times, okay, and it makes a bigger string. So that is one operation, and the other operation plus means concatenation operation. So what this does is, it will take 2 strings and then it will join these strings together. Okay. So here another thing I want you to notice, so this hash symbol. So in Python program, if you want to write a comment, so which should not be executed in your program, you can use this hash symbol and you can write anything after that, that will not be executed in the program. And using comments is very useful, because when you write a program and if you look at the program after a few months, so you may forget what you have done using with your variables or your statements. So if you use this comments, it will be you can easily find out what your program is doing. Another way of writing comments in Python is using 3 quotation symbols, and you can write your comments here and then close again with 3 single quotes. So this is another way of writing comments. This is also called block comment. So yeah, so we have seen the multiplication and this plus operations using in the context of strings, and now there is another operation. This was also seen in the first slide. So which is a string keyword. So what this does is, it takes the number 633, it converts it into a string 633, and it joins this to the previous string, and it makes a single string. Okay. And in Python you can also find out the length of a string. For example, if you want to know how many characters are there in a string, you can use this length command, which is inbuilt command, to know the number of lines in a string. And most of people may be working with MATLAB. So I want to emphasize here the key difference between Python and MATLAB here is, in Python, so the indexing starts from 0. So what do I mean by indexing is, so the counting, I mean how do we count the members of a string? So the counting starts from 0. If you know MATLAB before, so the difference is, in MATLAB the counting starts from 1. Okay. So if you are switching from MATLAB to Python, be careful to remember this point. This is very important. So for example, if you want to print a particular character in a string, like 10th character or first character, so we can use this square braces, and inside the square braces we can give what is the index of the character that we want to print out. So we can just say print, and we can give some string. So this will give the letter I at the output. Similarly, another important thing in Python is, you can, if you don't know the length of a string, for example, you don't know if there are 40 characters or 100 characters, but if you want to know what is the last character, you can use this -1. So -1 means the last character. Even if you don't know the length, if you just say -1, it will print the last character in the string. Okay. You can also you can also index group of characters like 7th to 13th or first to 5th character using this command. Here you use the starting index and then use semicolon and the last index. So here 7th to 13th characters will be printed at the output. So now let us try some of these in the Python shell. So I is a variable that is storing the value of a string, that is optical engineering. So now let us see what happens when I say. So now the optical engineering string has been made into a bigger string, repeating itself 4 times. And now let us see I plus. So the output is optical engineering E5502. So even though we have done this operation, this is not going to affect the value of the original string. So if you print, so I is still going to be optical engineering and we have not changed the value of I. But if you do this, so now if you try to print, so now the value of the string is modified, okay. And we have seen the concatenation and multiplication. Now we will see if we can convert numbers to strings and then add to I. Okay, so now it has added 2019 character to this, but if you without converting, if you try to do this, so it will give an error because integer and string are different types of data types and you cannot merge them together, okay. So now we have seen different types of operations on strings. Now let us try to write some simple program, okay. So far what we have been doing is we are opening this Python shell and then we are typing different commands, arithmetic or comparison, whatever commands we are typing in the shell. This is not a very good way of writing bigger programs. For example, if you want to write a big simulation program or if you want to create some application, so you cannot open this command and write your application because it gets executed after each statement. So instead what you can do is you can open a text file, for example. So you can open this editor and you can open a new file and you can write all of your program in this file and then you can execute the whole program at once instead of executing one after another, okay. So in order to open this program, I hope you already installed, go to nthought and you can open this code editor. So when you open this code editor, it will open like this. So here you can start writing your programs. For example, I will write a simple program. So what happens here is when I execute it, so all the statements in this file will be executed one after another, okay. So now let us go back and see the simple program that we want to write. Yeah, so before going to this program, I want to introduce another important thing. So in some of our applications or some of our programs, so we want to take input from the user or we want to add some number into our program so that the program will work based on the input that we give, okay. So far we haven't seen how to give data to Python. So in Python, so there is this command that we use to enter value into the program, okay. So the main command is raw_input. So raw_input takes your data from the console and then if for example you can give whatever so in raw_input whatever the value you enter, it will be by default a string type, okay. So as I have said before, you cannot do arithmetic operations with strings. So you have to convert it into appropriate type of data type, whether it can be an integer or float, okay. So in this example what we are going to do is to calculate the focal length of a lens, okay. So the focal length of a lens is given by, in order to know the focal length of the lens, you should know its radius of curvature and the material of the lens, okay. So for example, if this is the lens and this is R1 and this is R2 and if n is the refractive index, the focal length is given by 1 by f equals to 1 by R1 minus 1 by R2 into n minus 1, okay. So now we are writing a program to calculate a focal length. So given the values of radius of curvature 1 and radius of curvature 2. So in the first line we have declared the refractive index n to be 1.5 and this value we are keeping it as constant and we are not taking from the console, but we want to take the radius of curvature from the console. So we know that radius of curvature is a float value, it can be float value. So this raw input, whatever we receive from raw input will be converted into float, okay. So you can also in the raw input command you can give a string. So what happens is when this executes, so this statement will be prompted on the screen so that you will know what is the expected value from you. So if you don't include this string, so it will just give a blank space, so you don't know what you are supposed to enter. Okay. So to understand this program, okay, and this is the formula that we calculate, that we use to calculate the focal length, and capital F is this, and in order to know the focal length, we just have to calculate 1 divided by capital F, and finally we want to print the focal length of the lens is so and so value. So now let us go back. I have already written this. Okay. So now let us try to run this. So here at the bottom, if you see, it is asking for the radius of curvature. Let us give some value, and it is asking for the radius of curvature of a second surface. So now it has calculated the focal length and it is printing the value of focal length. Okay. So now let us try to modify this program a bit. So what if I remove this line here? Okay. I just gave raw input, and then this raw input is being converted into float. So if I run this program, and it is not asking enter the radius of curvature of length, but it is just blinking, it is waiting for us to give a number. So if I say 5, so now it is going to the next line where we have given the string and it displays. So what is the radius of curvature of the R2? So this is more informative. I mean, you will know what you are supposed to do. Okay. So now let us give some other value. So now it has again calculated the focal length and the value is 8.33. Okay. So you can write any kind of string inside this, and now we will run it. So it will just say enter R1. So this is the focal length. Yeah. So I hope you all understood how do we write a simple program and how it runs in Python. And these are the observations that I want you guys to make at this point. So as I have said before, this hash symbol is used to write comments. So this is very useful when you are looking at your programs after few months or few weeks. You will know what is your program, each line of your program doing. And another thing is, so the program is executing in the order that we have written. Okay. So it is not executing first line and then it is jumping to third line, it is not doing all those things, it is just executing one line after another line. Okay. So this is good in most of our programs, but what if you want to execute a particular part of your program when a particular condition is met? Okay. So for example, you have 2 radius of curvature values are given. So you want to use one formula if the you all know there is thick lens and thin lens, right? So for example, if you want to write a program and you have 2 different formulas. Obviously we have 2 different formulas to calculate focal length for a thick lens and a thin lens. So when you ask the thickness of the lens, based on the thickness of the lens, you want to use either this formula or that formula, right? So in order to do that kind of branching in your program, so we need something called conditional statements or branching statements. Okay. So we all know what are conditional statements from other programming language, the if and else statements. Okay. So this is the way these programs execute. So you have a bunch of program lines, and after a particular line you arrive at a point where you want to decide either I want to run this part of code or I want to run some other part of the code. So you write a test case. If the test is true, so you will write this, you will execute this bunch of code, and if the test is false, you will run other bunch of lines, and finally you will go to the next part of your program. Okay. So in order to understand this, so I want you to see this program. So here what we are doing is we are asking the user to enter a number, and we want to check if it is an even number or an odd number. So in order to check a given number A is even or not, so the simplest test is to do percentile with 2, and if the percentile operation is 0, it is an even number, and if the percentile is 1, it is an odd number. Okay. So the same thing we have written a simple Python program. So here what we are doing is we are using raw input command to take the value from the user, and we want to convert it into an integer here rather than a float like before. And here we are using an if statement, and in this if statement So, we are calculating the percentile and the output we are comparing with 0, and if it is true, as I have said before, there is no open and close braces in Python. So, we have to use this semicolon, and after semicolon, the moment you enter, the Python editor itself will give this extra spacing, and here you have to write your whatever commands you want to write. So, here we want to say it is an even number and we use this command, and if this condition is not true, so the program will come to the else statement, and in else statement we want to say x is an odd number, and finally after these two are executed, the program comes here. After one of these gets executed, the program comes here and we say I finished checking both of the conditions. Okay. So, now let us go back to our Python. So, this is the same program I have shown before. So, if I run this, so if I give for example 25, so 25 is an odd number. What happened here is, so it calculated 25 percentile 2, since it is not equals to 0, it does not go into this branch and it goes to the else branch, and in else branch it prints this x is an odd number and finished both conditions. Okay. So, similarly if we give an even number, so it says x is an even number and it finished both of the conditions. Okay. So, another thing I want you to notice in this is, so after you wrote this statement, if you press enter, so it is still, the cursor is still at this point, it has not moved to the starting point. So, instead of writing else here, if you write else, so it will not work. Okay. So, if you want, in order to write the else statement, you have to come all the way to the starting and then you have to write. Otherwise, if you write the statement here itself, so what happens is, for example, if you say a equal to 2 or something, 3 or something, so the program will execute in this block. Okay. For example, if you want to execute the statement irrespective of what happens, so I mean you cannot write it here because if should be followed by else. So, you have to move to the starting, okay, or else I will demonstrate what happens if you, okay. So, now you have seen, so if you do not write it here, for example, if you write this statement inside an else statement, if you execute, so we gave an even number, x is an even number, and it has not printed this particular statement because it is inside the else block. For similarly, if you give an odd number, since this is an odd number and the program is going inside the else block and it is printing both of these statements. Okay. So, you always should keep in mind where your next statement is going, either if you want to include it in that block or if you do not want to include it in that block. Okay. Yeah. So, these are the observations that I want you guys to make at this point. So, the percentile operation is used to calculate the remainder, and this double equal is used to comparison, and single equals to is used for assignment, and indentation is another important thing when you are writing if or else or for kind of statements. Okay, now, so now that we have seen conditional statements, so let us try to write another example program. So, in this example we are trying to model what happens when an object lies at a distance x from your lens. So, okay. So, we all know based on the object distance from the lens, the image distance is going to depend, right. So, this is the program I want you guys to open. So, the user has to enter the focal length of the lens and the user has to enter the object distance, so which is this distance. So, based on these two values, so it is going to say if the image is going to be real image or a virtual image, or if the image is going to be inverted or upright image, and about the position of the image, whether it is going to be at the infinity or it is going to lie within f or 0 to 2f. So, it is a simple program that uses the conditional statements. So, I will quickly run this program. So, we will just give some focal length 10 and object distance 25. So, with this parameters, So the lens is a convex because the focal length is positive. We know the focal length, if the focal length is negative, it's a concave lens, right? So because here focal length is positive, it's a convex, and image is going to be inverted and smaller. It's not going to be magnified, it's a smaller image, and location is going to be between f and 2f to the right of the lens. So that is the information. So the program is giving you based on the value of focal length, and let's try to give some other values, maybe -5 and 20. So here the lens is a concave and the image is going to be to the left of the lens, and it's upright, and it's again a diminished, not magnified image. Okay. So now let's go to iterative statements. So as I said before, if you have a block of code that you want to run multiple number of times, instead of copying the same code so many number of times, you can use these iterative or looping statements. So in Python we have two different types of loop statements. One is the for loop, and the another one is while loop. So this is how the iterative statements in Python works. So you have a block of code, and after the block of code you have another block of code that you want to execute multiple number of times. So for example, if you want to run it 10 number of times, you have to check. So how many, what is the iteration number? So if you want to exactly run 10 number of times, you should keep track of the iteration, right? Whether it is first iteration or second iteration. So for that there is a test to see what is the iteration number. Based on that, if it is true, it will go to the block of code and it will execute the statements, and again it comes back and it checks the condition. If the condition is false, it will exit the block of code, and then it moves on to the next part. So here I have shown an example of a while loop. So here while loop, what it does is, so the keyword to use a while loop is a while, and then this is the condition. As I have said, we have a test condition. So this is the test condition. Based on the test condition, this is the block of code that I want to execute. Okay. So if the condition is false, it will stop executing this block, and then the program will start executing from this point. Okay. So this is how a while loop works. So in this program, I want to calculate square of a number. For example, if you give a number a, so I want to calculate a square, right? So how I did this in this program is, so for example, a square, so a square can be given by so adding a number of times, right? Or for example, if I want to calculate 5 square can be calculated by 5 plus adding 5 times. Okay. Similarly, you can calculate 2 square by adding 2 times, right? So this is the algorithm I use to calculate a square of a number. So as I have said before, you can also use this double star operation. So just to demonstrate how to do a while loop, I have written this program. So here initially we want to take the number that we want to calculate square. So I use this command and I convert it into an integer, and we have declared a variable answer to be 0 initially, and finally whatever is the answer we are going to store in this, but initially we have initialized it to 0. And number of iterations, as we have seen here, if you want to calculate 5 square, so it has to add 5 times. Similarly, if you want to calculate 10 square, you have to add 10 times 10 number to itself. Okay. So we have the number of iterations here is going to be the number itself. Okay. And we have written a while loop. So the condition here is, so number of iterations left equals, if it is not equals to 0, and we go back and then we add answer to the number itself. Okay. And then we decrement the number of iterations by 1. So now I will explain in the case of 3 square. So initially we said answer equals to 0 and number of equals to 3. During the first iterations, so it will compare 3 to 0, and since 3 is not equals to 0, it will enter the while loop. Okay. So inside the while loop, it says answer equals to answer plus x. So answer is assigned a value of 0 plus 3. Okay. Now the answer value is 3, and in the next statement we are reducing this value to 2. Okay. So again we come back to the while loop and we check if this value is equals to 0 or not. Since 2 is not equals to 0, so it again comes back into the while loop. Again we add the answer 3 plus 3 because earlier answer was 3. So now it becomes 6 and we are decrementing the value to 1 here using this statement, and again we go back to the condition, we check 1 is not equals to 0, we again go back in the while loop and this time we add 6 plus 3 is going to 9 and we decrement the value of iter equals to 0. We again come back to this point and we check 0 not equals to 0, which is false. So now we do not go into this loop, we exit this and then we directly come to this statement. Here we print square of, we converted x to string, so and so number is so and so. So this is how a while loop works, and these are the observations I want you guys to make at this point. So for an iteration to work, you always have to set the iteration number of iterations outside the while loop. Okay, you cannot set this variable inside, you cannot say number. So in order for this to work, it should already been declared, okay, before the while loop. And another thing is the test variable should be decremented. So here this is the test variable, we are testing the while loop based on this variable, and this should be decremented inside the while loop. For example, if you do not decrement here, what happens is, so whenever you check the condition, it is always going to be 3, right. So 3 is not equals to 0, this is always true. So what happens is this while loop goes into an infinite loop. So in order to avoid that, you always have to make sure, so your test variable will fail at some point of time. So if it does not fail, the program is going to execute infinite number of times. So that is the second observation, and yeah, okay. So these are the observations I want you to make in the case of while loop. And the next, okay, okay, this is the program that I showed on the slide. So let us give 5 and the square of 5 is 25. Let us run it again and give some other number. So 225 is the square of 5, oh sorry 15. Okay. Yeah. So now we have seen one type of iterative statement, which is a while. Yeah. Yeah, okay, please. So the next type of iterative statement is a for loop. So for loop is a little different from while, and this is the syntax for using a for loop. Okay. So for loop followed by some variable name, and this should be in a series of sequences and a block of code followed by that. So what happens here is, so to see this, I will show some example. So here the example that we are seeing is to find the factorial. So factorial of a number 5 is given by 5 into 4 into 3 into and so on until 1. So this is how you calculate a factorial. So again we have used this raw input command to take a number from the user and initialize the answer to 1, okay, and finally we store our final result again in this variable, but initially we declared it as 1. So this is the syntax for loop. So in for loop we are declaring a identifier, also some dummy variable. Here the dummy variable is I, and we write another thing here is range of 1 comma x plus 1. So what this range function does is, if you say range of n, it will generate a list of values from 0 to n minus 1, okay. Similarly, if you say range of a comma b, so it will generate a series of integers a to b minus 1, okay. So to verify this, let us just go back to our Python shell again. So this is an inbuilt command, range of 5. So the output is going to be 0 to 4, not 5, 3 comma 6. So it is going to be 3, 4, 5 again, not 6. So you also have to remember, so it does not go all the way to the b, it goes only to b minus 1, okay. So in this first statement, in each of these iterations what happens is the value of I is assigned to one of these numbers sequentially, okay. So initially when the for loop is started, so the I value is equals to 0 and answer equals to 1, multiplied by 1 because the value of answer is already 1. And in the next iteration, so again here okay, sorry. Okay, so I will explain this program by using an example where we calculate the factorial of a number 4. Okay, so here x is equal to 4 and answer we have initialized to 1. So again, as I said before, the range command 1 comma 4 plus 1 will give 4. So these are the values returned by this command. So when the loop is initially started, I value on first iteration, I value and answer value we will see in this table. On the first iteration I is 1, answer is 1, right. So after the first iteration the loop goes back again. So initially I is assigned 1, after the first iteration I is assigned 2 here. So now I equals to 2 and the answer is answer multiplied by I, okay. Answer multiplied by, sorry, it should have been I. So it is 1 into 2 and again the control goes here and this time I is assigned a value 3. On the third iteration I is 3 and the result is 2 into 3, and on the fourth and final iteration, so the value of I is assigned 4 and 6 into 4, 24. So after the fourth iteration, so there are no more numbers in this series of numbers. So the loop exits at this point and then it prints this statement factorial of a given number is so and so, okay. So this is the difference between a while loop and a for loop. So now let us open this program. Yeah, so this is the same program. So here let us give 10 and the factorial is, so this big number, we give 3, factorial of 3 is 6, okay. Now we have seen all the basic building blocks required to write any Python program. So there are types of variables, arithmetic operations, conditional operations, Boolean operations, and comparison, like if you want to see a number is bigger or smaller, which is greater than, less than, and finally the iterative statements, the while loop and for loop. So with all these tools you can write now any program that you want. So I have shown some example here, so which is calculating root of a given number. So this program utilizes all the basic building blocks that you have learned so far, starting from different variables to the iterative statements. So to understand the problem, let me explain what we are going to do here, okay. So we all know what is Newton-Raphson method, right. So according to Newton-Raphson method, so if you have a polynomial p of x of this form, and if you want to find a solution for this polynomial, a solution is R such that p of r equals to 0. For example, let us take a polynomial, or for example in this example we wanted to calculate the root of a number x. So in order to find the root of the number, so we so let us say, so for example if you want to calculate the root of a number a, right, and let us assume the root is x, okay. So if square root of a is x, then x square minus a equals to is going to be 0, right. So we are using this principle to calculate the square root of a number. So for example if you want to calculate the square root of a number 15, so we have to solve this polynomial x square minus 15 equals to 0, okay. So this is our polynomial, and according to Newton-Raphson's method, so for this x square minus 15 equals to 0, let us say we have a guess for x, okay. So since 15 is closest to 16, so the root can be 4, so our root cannot be 4, it will be closer to 4, or we can also guess it is closer to 3. So initially we have to make a guess what could be the solution for this equation. We can say 3 is the closest approximation to the actual solution, and according to Newton-Raphson method, if this is your guess, this is going to be much better guess than what you already guessed. Okay. So the modified guess is given by g minus p of g by substituting this guess in your actual polynomial divided by substituting again this guess in the derivative of your polynomial, right. So this is the basis of Newton-Raphson method, and let us try to use this approach to calculate a square root of a given number. Okay. So as we have seen before, let us say k is your given number and you want to calculate the square root of this polynomial. So for this we have to use this equation x square minus k equals to 0. This is our p of x, and the derivative of p of x, p dash of equals to 2x, right. So now according to Newton-Raphson method, so if you have a guess, so you can have a better guess by substituting your new guess, or we say let us say g dash equals to g square minus k divided by so on. So this equation. So this is the program that computes our square root, and I will explain what each of these lines of this program is doing. So let us say epsilon is a number. So what epsilon does is how close you want to find the root to the actual root. Okay. So if square root of 16 is 4, how close you want to find, how accurately you want to find 4, whether you want, if you are maybe you are you satisfied if you get 990, or are you satisfied if you get 9990. Okay. So how accurately we want to find the root is given by this epsilon. Okay. And this statement, as you all know, we are taking input number from the console, and we can also find square root for a float type of number. So this can be either integer or it can be a float value. Okay. And so how do we get a reasonable guess? Okay. So what is a good starting point to guess what could be the root? So a good point to start the guess is to start, if you want to find the root of number 15, you can start by 15 by 2. Okay. In most of the cases, so half of the number is a good starting point to calculate the square root. So in this case we have said guess is half of the actual given number, and here we are using the while loop to calculate the square root of the number. Okay. So in this while loop, what is happening is, so for example, if guess is our actual root. Okay. In this example, let us assume, so you actually guessed the solution right away. For example, if you want to find the square root of 16 and your guess is 4, so guess square, which is 4 square minus actual number 16 is greater than or equals to your epsilon, okay, which is true, and it won't execute this block of statements, and your result is already given. Okay. On the other hand, so if you have guessed the square root to be 2, okay, so now what happens? 2 square 4 minus 16, which is 12, and the here absolute command calculates, it converts negative to positive numbers, it takes only positive numbers. So 12 is greater than or equals to your epsilon, so which is true, so it goes into this while loop and your guess is updated by this equation. Okay. So your previous guess was 2, right? So now what you are doing is replacing your previous guess 2 minus guess square, which is minus 12 divided by 4, so which is going to be some other number. Okay. So we come back here, we use the new guess to calculate this check, and then we keep updating the value of guess and until finally this condition fails, which means we have approached very close to our solution, right? And after that we stop the iteration, and then finally we print this is the approximate solution. Okay, now let us just open the program. Okay, so this is the same program, and let me run it. So we will give 16, square root of 16 is approximately 4.00012. So if I increase the epsilon, I mean if I make it even more closer, So, if I give the same 16, it is going to be even more accurate. Okay. So, you can change your accuracy just by changing the value of epsilon. Okay. I hope all of you understood, so whatever is explained so far. So, we have seen whatever is necessary to write a simple program in Python. So, in the next class we will see vector data types and plotting and NumPy library of Python. So, that is it.